It is my privilege to present the following program that was inspired by the way American businesses and organizations have responded to the events of September 11th. It's part of a special series produced by Heartbeat of America. Having served in the United States Navy for many years, I fully appreciate the important role small and middle-sized businesses play in the very fabric of our country, and I salute the professionals who lead these companies and thus keep America strong. They are the very backbone of our free enterprise system, and today on this program you will meet the individuals behind one such organization. I'll be back later in the program to introduce the Keeping America Strong Award. And now, let's learn more about the organization we are honoring today.
Today, the eyes and ears of the 21st century are focused on new developments, new technologies, new emerging companies. We're on the scene to bring it to you as it happens.
We anchor from our new studios in Los Angeles and then go out all over America to get to the heart of the story.
I'm Bert Tenzer.
I'm Bella Shaw.
I'm Doug Llewellyn.
And I'm William Shatner, and this is Heartbeat of America. Since 2001, our television series has been featuring entrepreneurial companies that move our country and our economy forward. Standing by at our studios in Los Angeles is one such company. Welcome. Good to have you with us.
Thanks for having me.
All right, let's begin by telling me what you do and who benefits from it.
Well, our company manufactures a cured-in-place pipelining system that goes in the existing pipe underground. The reason this is developed is because the existing structure has failed. The pipe is damaged, whether it's roots, cracks, and is taking on infiltration or exfiltration into the existing ground around the pipe.
Well, you're obviously successful. So what do you attribute your success to? Any particular philosophies or strategies?
I believe that we have the best materials for the pipelining product. It has a 50-year minimum lifespan, and we also have the technical support to back up the product out in the field.
Now, stay with us. There's more to come.
Thank you very much, Mr. Shatner. Continuing now with our interview here in our Los Angeles studio, I'm Doug Llewellyn with our guest. On my left, Jerry DeHulster, who you've already met. He is the president and the CEO of our guest company, which is named Permaliner Industries, Inc., headquartered in Largo, Florida. And on Jerry's left, by the way, is Doug McCullough. He is a director of operations for the company. Gentlemen, welcome. Nice to have you here.
Thank you,
I should point out this company is very well known for what they do. They get a lot of publicity in the trade. Here's their picture on one of the trade magazines, Trenchless Technology. I didn't know there was such a... I should be reading this, I guess, every week, right? I've got to get a subscription to this. Anyway, your picture's there. You look good.
Thank you.
Let me ask you, gentlemen, to begin. Tell me, what are the big problems with the pipes that you gentlemen, that your company deals with? What's the big problem that causes you to get involved?
The aging infrastructure. A lot of the pipes that are underground, I'd say probably 90% of them right now, are past its lifespan. With that, they start to deteriorate over time, and when they start to deteriorate, exfiltration, sewage going into the environment, as well as extra water coming into the existing sewer pipe, causing the municipalities to treat that extra water as sewage water.
So we're talking about pipes that are made of what, for the most part?
Concrete, clay pipe, that's what we have here. You have pipes called Orangeburg. You have cast iron pipes.
Now, some of these pipes could be, what, 50, 60, 70 years old?
Pretty much a minimum lifespan, or the maximum lifespan on a pipe is about 50 years old.
All right. This is a clay pipe.
That's correct.
This is a sample, an example of what you're talking about. Obviously, this is one that, an example, maybe a tree root could have gone through this, right?
That's correct.
In any event, the pipe has been penetrated, and if this were underground, it'd be leaking. Mm-hmm. So you have come along, and what have you done to correct this?
We developed a system made up of a felt material and PVC. It's put into a tubular form. Then we impregnate it with a two-part epoxy resin. Then the actual liner tube is inverted into the existing pipe without using the conventional dig and replace methods.
Well, we can actually see this now. You want to point out parts of this, what we're looking at?
Well, the outside casing of it is, of course, the clay pipe. That's majority of the pipe. In different parts of the country, it's majority of the pipe that's in the ground.
Right.
This pipe is, it becomes brittle, it cracks, as you can see when we had it turned the other way with the hole in the side. What we've done is we've inverted the pipe, and you can see the uniform thickness of our tube, and you can see the white material here and you can see the liner on the inside. It's uniform thickness all the way around. The resin migrates out into the cracks, open joints, even missing pipe sections, and it will seal those areas off. Once this liner is cured, over a period of time of about 2 to 3 hours, it becomes structurally sound, and it meets the standards of ASTM F1216 for cured-in-place pipe.
And if you turn around, what we're looking at through the hole here, that is the resin from your liner that has gone in there, right?
That is correct. You can see where it migrates out, and it actually seals the void.
So the pipe then, for all intents and purposes, is back in usable condition?
Yes, the existing pipe, even if it was to deteriorate over a period of time, the new liner inside will act as a brand new pipe.
And how long would it might be good then before you have to actually go in and replace the whole pipe itself?
Our liner's tested to the ASTM F1216 specification, which requires a minimum lifespan of 50 years.
50 years?
50 years. We've actually, third-party testing facilities testing our liner has given us back test results showing it closer to 100 years.
You're kidding. Well, that could save communities a significant amount of money.
Yes, it can.
Obviously. All right, so how was this developed? Did you develop this?
Yes, I did. Developed this back in 1998 using what I knew from the industry, being in the industry for many years, and looked at what was offered out in the industry at that point. Came and got together with some material developers, developed the bag. Well, they actually developed the bag with us, and then basically got together with some chemical manufacturers for resin and came up with a suitable resin for the makeup of the rest of the liner.
Is it a good time to show this? Because this is really what goes
Sure.
into the pipe, right?
Mm-hmm. Yes.
Let's put this out here and here. We'll do it this way and let you show what it is. This is
Okay.
looks like a plastic hose almost.
Yeah, so well, on the outside here you have a flexible PVC coating. The PVC coating is then applied to the the felt. The felt is a 3 millimeter thickness, and it has a reinforced scrim in between the felt and the actual coating on the outside. What we do is we then put it through a machine, and it actually seals it together in a tube form. These are all sized to go in different size pipes. This
Right.
one here would be sized to go in a 4-inch pipe.
And does it get inverted, or does it go in like that? The felt is next to the outside of the pipe?
That's correct. What we would do is we would impregnate this tube with a 2-part epoxy resin. Once impregnated, we would load it into a specialized piece of equipment which we manufacture.
Right.
The machine would then pressurize this material to turn inside out, and I kind of folded it back to show you what it would look like
Right.
as it inverts out. And that's, you can see here, if you see this white tape seam here, you can actually see the white tape seam inside the liner material here, and that's it actually inverted out inside the pipe.
So that's what it looks like. And obviously you have this in many different sizes to configure whatever size pipe you're correcting.
That is
right?
correct, yes.
What's the hat? This looks like a cute little hat here. Explain this.
Okay, this is a different process. Whereas if you had, if you were dealing with a sewer main, and say it's a collection line that collects all the sewer laterals coming out of a house or a business throughout the distance of the street, and the laterals tying in and the connection's broken. Well, this liner here would repair the sewer line coming from the residential homeowner building, whatever it may be.
Right.
This would repair it down to that point, but not the actual connection point. What this would do is actually put a seal around the inside of the collection line, being the mainline sewer, okay? And then what we would do is we'd invert this portion of the liner up into the lateral so you get a complete seal there at the main. And we can do these in lengths from anywhere from a foot up to 120 feet in length.
Well, it's kind of a fascinating story about a company that is producing this. Now, you manufacture this, am I right?
Yes, we do.
And where do you do this?
We do this in Largo, Florida.
And Jerry, hey, Doug, I'm sorry.
Yes.
Doug, tell me a little bit about the manufacturing process of this.
Manufacturing process takes place in our facility where we actually fabricate the liner. The epoxies are blended there, and we are basically shipping from our facility nationwide, all across Canada, Puerto Rico, Guam, Hong Kong, worldwide.
So this is really in pretty widespread use at this point. How long have you been in business doing this?
We opened our doors in January of 1999.
So you're really a young kid on the block, so to speak.
Yeah, this industry is very new.
It is?
Yes.
Do you install it, or do you train the people who install it?
That's